Advanced Filtering Techniques in DynamoDB, a comprehensive guide. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. DynamoDB, Amazon's fully managed NoSQL database service, is renowned for its scalability, flexibility, and low latency. However, one of the aspects that sets it apart from other NoSQL databases is its unique filtering mechanisms. This podcast will delve into DynamoDB's advanced filtering techniques, compare them to other NoSQL databases, and provide insights on determining the optimal filtering strategy for various use cases. Understanding DynamoDB's unique filtering mechanisms compared to other NoSQL databases. DynamoDB stands out with its distinct approach to data filtering. Unlike many NoSQL databases that rely heavily on complex query languages and secondary indexes, DynamoDB leverages its primary key schema and built-in filtering mechanisms for efficient data retrieval. Here are some key points to understand. Primary key-based filtering. DynamoDB uses a partition key and, optionally, a sort key to filter data. This approach ensures high performance and scalability by organizing data into distinct partitions. Filter expressions. DynamoDB allows filter expressions to narrow down the results of a query or scan operation. Filter expressions are applied after the initial data retrieval, making them ideal for reducing the size of the result set without significantly impacting read capacity units. Indexing. While DynamoDB supports secondary indexes, both global and local, its primary key schema often negates the need for extensive indexing strategies seen in other NoSQL databases. This simplicity can lead to easier maintenance and cost efficiency. In contrast, other NoSQL databases like MongoDB and Cassandra rely more on secondary indexes and complex query mechanisms. MongoDB, for instance, uses a flexible query language and various index types to support diverse filtering needs. On the other hand, Cassandra employs a distributed architecture with clustering keys and secondary indexes to achieve similar outcomes. Exploring two distinct filtering approaches in DynamoDB, a comparative analysis. To effectively utilize DynamoDB's filtering capabilities, it's essential to understand the two primary approaches: query filtering and scan filtering. 1. Query filtering. A query operation in DynamoDB finds items based on primary fundamental values. This method is highly efficient because it directly accesses the relevant partitions. Primary key queries. By specifying the partition key, and, optionally, the sort key, you can efficiently retrieve items that match the criteria. Filter expressions with queries. After fetching the initial dataset based on the primary key, filter expressions can be used to narrow down the results further. For example, if you have a table of customer orders, you can query orders by customer ID, partition key, and filter by order status or date. 2. Scan filtering. A scan operation reads every item in a table or a secondary index. While it can be more resource-intensive than a query, it allows for comprehensive data retrieval. Full table scans, useful when analyzing or processing large datasets without specific partition key constraints. Filter expressions with scans. Similar to query filtering, filter expressions in scans help reduce the result set size by applying conditions post-retrieval. For instance, you can scan a table for all orders and filter to find those placed within the last month. Determining the optimal filtering strategy for various use cases in DynamoDB. Selecting the right filtering strategy in DynamoDB depends on the nature of your data and your application's requirements. Here are some guidelines to help you choose. High selectivity with known keys. Query filtering is ideal if your queries are highly selective and you know the partition keys. It offers faster performance and lower read capacity usage. Broad data analysis. Scan filtering may be more appropriate for use cases requiring broad data analysis, such as generating reports or analytics. Despite being more resource-intensive, it allows for comprehensive data retrieval. Dynamic querying. If your application demands flexibility and you cannot always predict the partition keys, consider using global secondary indexes, GSIs. GSIs enable querying on non-primary vital attributes, balancing performance and flexibility. Cost efficiency. Always weigh the cost implications. Due to their targeted nature, query operations are generally more cost-effective. Scans can be expensive if not managed properly, so use them judiciously. In conclusion, mastering DynamoDB's advanced filtering techniques requires an understanding of its unique mechanisms and strategic application of query and scan filtering methods. You can achieve optimal performance and cost efficiency in your DynamoDB deployments by aligning your filtering strategy with your use case requirements. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.